Hello guys, how are you today? Today we are gonna actually look at the asymptote, the horizontal asymptote of a function. And we know that to find that horizontal asymptote, we have to look at the problem as a limit problem. So Hossein is going to help me solve the problem of finding the horizontal asymptote of f of x, as you can see on the screen. So hello, Hussein. How are you today?
Hi, Amir. I'm good. Thanks. Long time no
Very
see.
good. Yes. Okay. So floor is yours, Hussein. Please go ahead and solve the problem.
Okay. So the problem is finding horizontal asymptote of this function f of x. It's a rational function, and the numerator I have e 2x plus 3x minus 2. On the denominator, I have 6x minus 1/3 to the x. Okay. So to find horizontal asymptote, we wanted to see how the function behaves when x is approaching infinity. So specifically, we need to find limit of f of x when x is approaching positive infinity, and then
Correct.
limit of f of x when x is approaching negative infinity. So I'm going to find two limits here.
And if we find a constant, that constant value is going to be the horizontal.
Exactly.
Because
So
sometimes
the
you
first
get
one,
infinity.
the first one, the answer might be a. A is a constant, so x equal a is the horizontal asymptote, and then b might be the answer to the second limit, and x equal b is another horizontal asymptote. And a and b might be different, might be the same, or they may not exist. So we're going to find out.
Yeah, please go ahead.
All right. So the first limit is the limit of e to the x plus 3x minus 2, 6x minus 1/3 to the x when x is approaching positive infinity. So on this side, I see a polynomial function, an exponential function. So as a general rule, I know that x to n is less than a to x. X here is a variable, and so this inequality.
The relative rate actually on the left side, it's a slower approaching to the, when you increase the x value. So on the right side, a to the power of x has a higher rate, so faster than x to the power of n as a polynomial.
Right. So this shows the rate of growth, and when x is approaching positive infinity, and this is true when a is greater than 1. When a is not, when a is between 0 and 1, then this limit, the inequality, is going to flip. So I'm going to have xn greater than a to the x when x is approaching positive infinity. Actually, I can use Desmos here to show it to you. For example, let's assume we have x squared, and then we have, for example, 3 to the x. So 3 to the x is the purple line here. And as we can see, when x is approaching positive infinity for large values of positive x, 3 to the x grow faster than x squared.
Yeah, the purple curve is higher than the green one. And at a point like x equals 1, we have larger value for the purple one. And if x increases, it goes faster to the infinity.
Correct.
So that's the relative rate of the curve. Correct.
Right.
Thank you for explaining that, Hussein. Okay.
So, okay, I'm going to go ahead and use this rule here. So this first term is an exponential, so it grows faster than the second term, 3x. So it's a dominating term. So I'm going to.
And the other one is constant too, so it doesn't matter. Yeah.
Exactly. 2 is not going to change when x is approaching infinity. So I'm not worried about that. So limit of actually the numerator, I'm only going to write the dominating term, which is e to the x.
Yeah.
And
Dominating term, yeah.
And then the denominator, I have two terms. One is 6x, which is the dominating term compared to the other one, 1/3 of x, because 1/3 is the constant value less than 1. And as you see on the right side, here, the rate of growth of xn or 6x is greater than the 1/3 to the
So
x.
we keep the dominating term in the denominator, which is 6x. Okay.
Right, right. The dominating term here is 6x. So I'm going to write that down here.
Sure, yeah.
6x, and I'm going to...
As x approaches to infinity, yeah.
Right, as x approaches positive infinity, I'm going to just get rid of the rest. And then if we look at this this shorter expression here, actually the numerator...
The numerator is dominating again compared to the denominator.
Right. The numerator is the dominating term. It's going to grow faster because e is 2.7.
Yeah.
2.718 is a value greater than 1, so it's going to grow faster than 6x. So the whole expression fraction is going to approach
to infinity,
positive infinity.
Correct.
Right. Okay, so this is basically what it says. It says that it doesn't have
any
horizontal asymptote.
Correct. It doesn't have any horizontal asymptote. Yeah, because it's infinity. There is no constant value.
Right. So I'm going to move on to the next limit, which is finding the limit of ex plus 3x minus 2, 6x minus 1/3 to the x when x is approaching negative infinity this time.
Yeah.
So
now we are looking at the other side of the
yes.
spectrum. Correct. Yeah.
Okay, let me see. I'm going to change the variable here. When x is, I'm going to assume z equal negative x, and then when x is approaching negative infinity, I have z approaching positive infinity. And then I'm going to rewrite this expression in terms of z.
Yeah, sure.
So limit of e to negative z, and this is minus 3z minus 2 divided by minus 6z plus minus 1/3 to negative z when z is approaching positive infinity.
Yeah.
And then so what I can do here, I have e to minus z, so I can rewrite that as 1/e to the z.
Yeah.
And then this 1/e is a value less than 1. And then I have 1/3, in the denominator, I have 1/3 to negative z, so I can rewrite that as 3 to the z.
Correct. Yeah.
So unfortunately, I got to the end of the page.
Yeah, you can add a page actually.
Right.
Yeah.
Okay. So I'm going to rewrite this limit. So e to negative z is going to change to 1 over e to z minus 3z minus 2 divided by minus 6, negative 6z minus 3 to
the power of z. When z approaches to positive infinity.
Positive infinity. Then, so if I look at the numerator, the first term is going to approach 0 when z approaches positive infinity.
Actually, you can just keep the dominating term, like the previous approach.
Right. What I'm trying to say is that this negative 3z is the dominating term. This is the term that is growing between these three terms on the numerator. And when I look at the denominator, this 3 to the z is
dominating
dominating term. So I'm going to rewrite this limit, and I'm going to only keep the dominating terms. So I have limit of when z is approaching positive infinity. So on the numerator, I have negative 3z. On the denominator, I have negative 3 to the power of z. And then if I look at this, here, the denominator is the dominating term. It's going to grow faster.
Because the base is greater than 1, which is 3 to the power of z. So it's going to be
So it's going to be 1 over infinity.
Correct.
Basically.
Which is 0.
And right. And then this eventually goes to 0. So that means that the horizontal asymptote when x is approaching negative infinity is going to be 0.
0. So this function has one horizontal asymptote, which is actually x-axis.
And x equals 0 is the horizontal asymptote.
Y equals 0.
Right.
Yeah, it's actually x-axis. Simply, we can just say the horizontal asymptote is x-axis, or y equals 0. The other one is infinity, which is not asymptote. Okay. Actually, the devil is in the detail, and when we approach the problem, we see the actually nice fundamentals of the algebra and also the calculus. Thank you, Hussein, for solving the problem, and I hope that our viewers find this video very helpful and useful, and please subscribe to our channel, and don't forget to hit this notification button. So until the next video, have a good day. Thank you. Bye.
Thank you.